Good. All right. Well, good morning, everyone. My name is Gene Jones. I'm with an organization called the Southern Waste Information Exchange. We're a small nonprofit out of Tallahassee, Florida, that assist industry with waste issues in municipalities. We kind of act like a matchmaker, putting waste generators in touch with waste users, as well as conduct events like this in the world of recycling, waste management, waste conversion, as well as remediation. Welcome to the 12th Waste Conversion Technology Conference. It's a pleasure to be back in person as well as virtually. For those folks that are attending virtually, welcome. We hope you get a wealth of information over the next day and a half here as we talk about waste conversion technologies, waste to energy, anaerobic digestion, pyrolysis, gasification, a host of different technologies that are being used to try to help solve issues with waste management. If you allow me, let me make a couple of opening comments. Hang on one sec. Let me go ahead and start this process off by telling you that this is our, I think, 5th or 6th hybrid event with regard to running in-person / virtual activities. I can't tell you after doing this that from 5 or 6 times now that we're not going to run into problems, because I can assure you we will. But I will promise you that we will do our best to try to solve those problems through the AV team of Dave and Tim in the back of the room and try to get through any glitches that we may run into. Real quickly, in terms of the final program and the agenda, it's all in the packet that we provided everybody as you signed in. In addition, the virtual participants, I did email that out to everybody. So you will have the speaker compendium, which has the abstracts and bios for everybody. So I am going to ask the moderators not to read bios in essence of time. They're just going to introduce the speaker and what they're talking on. I'm going to ask everybody to silence your phones. I got caught doing that yesterday, wasn't paying attention and left it on. So please silence your phones. Proceedings. We are recording everything. So everybody in the room, as well as our virtual attendees, will get the recordings after the event. It'll be next week. We'll also shoot all the presentations that you're going to see over the next day and a half to PDF format. Our VIP registrants are going to get the database at the end. So let me make this general comment. If you do not want your contact information released, please let me know, send me an email or just come up to me and we'll pull your contact information out of the database. Any problems, you can see myself, Norbert, my wife Dana out at the registration desk, or either Brittany Sullivan or Taryn Knight. They can help you. Bathrooms are just right down the hall. We do have a handout table in the exhibit hall. So if anybody wants to share some information, please feel free to use it. I have to just take a minute and thank our sponsors, because I can tell you, especially in a year of COVID, that if it were not for our sponsors and exhibitors, an event like this would not be possible. I really want to highlight Sierra Energy, Torex, and BMH Technologies, because they stepped up to the plate and provided cash to help make this possible. So it's like I said, without the sponsors, we wouldn't be able to do it. Also need to recognize Solid Waste Association of North America. They partnered with us. In fact, this opening session that we're going to be talking about this morning is all due in part to SWANA. So I want to thank David Biederman and Theresa Rademacher to help us put this session together. So without further ado, I'm going to go ahead and jump into our opening session, which is not that one, but this one. This particular session is going to focus on emerging issues for waste to energy facilities, PFAS. If you haven't heard of PFAS, you will. I can assure you this is an emerging contaminant that is raising a lot of eyebrows in multiple industries. We're talking about upgrades, recycling, and ash recovery. So with that, I'm going to turn it over to our moderator, Theresa with SWANA, and let her drive the train. Thank you and welcome.
I'm shorter than he is. Good morning, everyone. My name is Theresa Rademacher, and I am with the Solid Waste Association of North America. And I'm not going to speak to you a whole lot today. I'm simply going to introduce our speakers for this opening session. As Jean said, I won't be reading biographies, but I encourage you to read all of these gentlemen's biographies. They are impressive and they contribute a lot to the industry. So to start off, I would like to introduce John Carlton. He will be talking about insights on SWANA's research report for PFAS at the waste energy facilities.
Good morning, everybody. Welcome to San Diego. I'm actually based here in San Diego. My name is John Carlton, and I'm with HDR Engineering. We're a 10,000 person engineering firm, mostly in North America, but we do some work overseas as well. I run our national planning and consulting practice, and I am here at as a guest speaker, if you will, by SWANA. Jeremy O'Brien asked if I would help present on the recent report that they are working on, which is the fate and transport of PFAS in waste energy facilities. Better Living Through Science. I think it was a movie in the mid 2015s, but I think it does encapsulate, what many of us have come to expect from our society. I personally enjoy some of the scientific aspects of our technology. I have a Gore-Tex jacket that when it's raining and I'm out there hiking, I appreciate. But there are unintended consequences that come with some of these materials that we create as humans. And one of those is PFAS, perfluorinated alcohol substances. And those have been raising eyebrows probably for the last 20 years or so in terms of their potential health impacts, both from the environment as well as human health. And so the SWANA has been trying to look at these type of issues on behalf of their members, and this report is part of that current work product. A little bit about the SWANA Applied Research Foundation. It is the research element of SWANA, the Solid Waste Association of North America. Some of the members of SWANA contribute to the research element, which is to advance the practice of solid waste management. Jeremy O'Brien is the director, I believe, of the ARF. There's about 50 local government and corporate sponsors. They each contribute something to it. I think the government sponsors do about, I think, a penny per ton of waste processed to it. And they vote on what type of research they want to conduct. There are 4 different research groups within the ARF: collections, recycling, waste energy, and disposal. And so one of the research topics that the waste energy group decided to look at was PFAS, and how waste energy can potentially be a solution to PFAS. A note of caution on this presentation and in this report. This is an ongoing research project. It is not completed yet, has not been presented or approved by SWANA, but it's sort of being presented out there to help, again, advance the industry, advance the practice, get the conversation going, share what's been learned to date. My understanding is that this presentation is expected to be completed sometime early next year and will be released to the members. So with that, what is PFAS, perfluoroalkyl substances? Well, really, it's a group of about 5,000 chemical products that are man-made. They are used in a whole wide variety of things that we use. 2 of the most, most well-known are PFOA and PFOS, PFOS versus FAS. PFOS, FOS, are key ingredients in stain protection. So things like Scotchguard or water resistance, things like that. They're also used in firefighting chemicals. PFOA is the other one. It's also used in water and oil repellent fabrics like Gore-Tex, and as well as wax paper. So, I mean, these are products that are ubiquitous in our society. If you use a Teflon pan, it actually has PFOA in it. And we don't know, like, you know, I don't think when people develop these things, they know what the impacts of these are going to be after they do them. But they are, and it's in the amount of PFOA and PFAS in our waste stream is not well known. As we know, municipal solid waste is not a heterogeneous material. It varies from region to region. It varies from season to season. It varies based on economic conditions and manufacturing practices. But here are the larger components that contain of the waste stream that contain different PFAS. And this was an estimate in the report to try to capture about how much material is in the waste stream containing these chemicals. Carpets are probably one of the most significant one, given their stain resistance. And, everyone probably loves the fact that their carpets are, are less stain proof than they used to be. But they have these chemicals in them. Some of the high estimates are 15% of the material contains these chemicals. And when you try to look at the pounds per ton of MSW, there's a range there from 0.03 to 1.38 pounds per ton. So we're not talking a significant percentage of the waste stream. When you actually compare it to the total, we're talking a very, very small fraction. Clothing, footwear, paper, and sacks and other paper packaging are the primary containers. But one thing that we're trying to advance the science of is our understanding of what, how much PFOA and PFAS are actually in the waste stream. And that's one of the targets of this research. So we have actually, as manufacturers and producers, have reduced the amount of PFAS in our products since the late 1990s. And as a result, when we're talking about health impacts, we've actually seen declines in the amount of material that's in our bloodstream. If you look back to the late 90s, we actually had, fairly, I don't know if on this chart it looks significant, but you can see that trend is downward, and it has been and has been continuing to do it. The health impacts are not widely known, but some of the potential concerns include child development, affecting learning behavior of infants and children, pregnancy risks and potentially impacting the ability of someone to get pregnant, hormonal disruption, the potential impacts on cholesterol levels, immune system impacts, and potential cancer risks. Now, again, these are not, I don't think, defined understandings. These are things that we're trying to understand the links of this are. But again, once you start bringing that into the consideration, it's something to take in the take consideration of and try to understand. As society, we have been using thermal treatment of waste as a way to not only reduce the volume and the toxicity of waste, but also to try to deal with other aspects of it. This is a report that was put out by SWANA back in 2018. It was a lessons from Europe on thermal treatment of residual waste. It's available free to any SWANA member. So if you are a SWANA member, it is you can download this and kind of get a sense for what the lessons learned are on that. One thing we've understood about thermal treatment is it does help with things like pathogen destruction, chemical decomposition, but we haven't really studied that as well with certain compounds like PFAS. So that is where this report is looking to try to advance. The EPA has also been looking at this issue back, I think there's been 2 reports published, one in 1999 or 2019, I think one in 2021. looking at PFAS management through incineration. And, this report is suggesting that there is the ability to actually molecularly break down PFAS through thermal processes. They've put some standards out there, but it's not conclusive. For example, they do indicate that at least in the laboratory basis that molecular destruction of PFAS should occur at 1,000 degrees centigrade at a 1 second residence time. But it's not well known still. There's still a lot of research that need to be done on this. The US and Europe have set standards for thermal destruction of waste, and this is their standards currently. So this is where I think a lot of us are focusing on, what does it mean to thermally treat waste, especially from a PFAS standpoint. From a non-hazardous standpoint, the current standards for the US are 1,000 degrees C at 1 second residence time. So it's usually a combination of temperature and time. In Europe, it's a lower degrees centigrade, but a higher residence time. For hazardous waste, as you can imagine, higher degrees, 1,100 degrees C for 2 seconds residence time. So this paper has tried to look at the availability of research that's been done in this space. There's not a lot, and I'll kind of quickly run through some of that which has been presented in this paper. The first study that's been done really on this was back in 2005 by researcher Yamada. And it was the first study to really evaluate the thermal degradation of fabric, like stain-resistant fabrics or Gore-Tex type fabrics treated with PFAS under incineration conditions. Their study determined that 99.9% of PFAS was destroyed or thermally broken down at 1,000 degrees C, and that no detectable PFOA components were found in residuals. Another study by Taylor, 2014, looked at some of the fluorine-containing products that contain PFOA that could be metabolized into PFOA after they degrade. They determined that waste incineration of these polymers, which could have been a potential PFOA, did not end up creating PFOA as a result, and therefore the conclusion basically was that at 1,000 degrees C, 2 seconds residence time, PFOA was basically destroyed. Norway, this was a way to look at persistent organic compounds. Again, the PFAS was considered to be destroyed in the combustion zone, and that they looked at the APC, air pollution control devices, afterwards, and again, did not find PFAS to be in the air pollution control devices. There was a study done in, I think this is, I actually don't know where this is, but basically they were looking to look at hydrogen fluoride and to see if that would create any type of PFAS during incineration. Results were that at incineration conditions, no PFAS was created, and that therefore it was an acceptable waste treatment related to PFAS. In the Netherlands, there was a facility created in 2011. They were looking to try to look at persistent organic pollutants. This is a long-term study that was done, including measurements for PFOA and PFAS. They had produced data on this, looking at the amount of PFAS created, processed, and actually in the emissions. The destruction efficiency, when you look at significant digits, was basically effectively 100%. There was some, very, very low amounts of PFAS in the emissions, but again, looking at 99.9% plus in terms of destruction efficiency. So basically, again, this is a preliminary look at research. It suggests that are commercial incinerators that are running at 1,000 degrees C with residence time of at least 1 second. You do have PFAS being destroyed in waste energy. It is, if it's not done, at least it would be collected in the APC systems, but even those systems did not find where they did collect it, that there was even the PFAS being formed after combustion in the air pollution control systems. The effectiveness, though, is not well understood. The EPA is trying to do research on this. It's suggesting that a lot more research needs to be understood, and that EPA is, I think, looking to work with waste energy facilities across the U.S. to try to conduct full-scale PFAS testing. And with that, I would say I can try to answer any questions, but really questions probably should go to Jeremy O'Brien. And since he's not here, it's very easy to pass them off to him. But I thank you for your time. And I do encourage you to look at the study and consider it as you go forward. Thank you.
Thank you very much, John. Oh my gosh. So at this time, is there any questions for John? Okay. Oh, sorry, we have a question over here.
Hello, thank you. Great presentation. I just was curious in your thoughts on the timeline of when, so the information that you're talking about is going to be more widely known, because I work with a lot of food packaging companies, and PFAS and similar substances are already starting to show up on their lists of, things that cannot be used in our packaging. So a lot of times I know those claims come before the science, but what are your thoughts on how long it'll take for the science to catch up?
The great thing about making predictions at this point is that I can make them and you can't dispute them. So one thing I will say is that PFAS is obviously of national significance. A lot of states are looking at this from a legislative standpoint. I think there's a lot of research being done into this. I would say the next 3 to 5 years, it's probably going to take that long for some more conclusive, information to come out. I know that there are research projects is being done on other disposal aspects. So what happens to PFAS in landfills? What happens to PFAS in landfill gas? What happens to PFAS in leachate? So from a waste perspective, I think we are looking at all aspects of this. But I think it's going to be several years before we're going to have any type of conclusive remarks as to how to best manage PFAS, because it's not well understood yet.
Are you planning to add biosolids into your report? Because the EPA has noted that the PFAS are highly still prevalent when they come out of the anaerobic digestive process. So the next phase would be thermal conversion, destruction of biosolids post-AD, or get rid of AD altogether and just send biosolids through a thermal destruction.
So it's a good question. Anything that we're talking about waste products, so even human waste products or any type of waste products. So I think biosolids are going to be something that are going to be looked at. PFAS is in wastewater sludge. They're in wastewater discharges. Treatment technologies for trying to capture that right now, reverse osmosis is all that's being done to, and all that's going to do is, accumulate it. It's not going to treat it. So thermal right now is the only thing I've heard that is a way to treat it. I think it's going to be considered what is safe, how much lead is safe, how much arsenic is safe in either the discharges. I think that same question is going to be posed to PFAS, and it's going to be a question that we're going to debate for years. But you're right. I don't think there's any type of treatment that if it hits a certain level that's going to be able to do it except for thermal at this point.
Fantastic. Thank you all so much for your questions. Those are fantastic. And if you have an opportunity to read the report, it is very thorough. So next I'd like to introduce William Embree, who will be discussing waste to energy technology, enhancing the community environment.
Yeah, my name is William Embree. I'm the operations manager for Pinellas County Department of Solid Waste. We have what I like to call an integrated solid waste management system. Now, in the state of Florida, there's not many communities that aren't integrated. The only difference between them and maybe our system is ours is all on one campus. We have waste energy, we have landfill, we have chemicals collection, and tires, and a citizens convenience center. And we also have an artificial reef program. The state of Florida has provided the response or given the responsibility of disposal to county governments, which means all of the solid waste generated in Pinellas County comes to us. Pinellas County is the smallest land area. You can see kind of like that. That is a very good illustrative map of the size of Pinellas County relative to the other counties in the state of Florida. We also have the highest population density. That's another way of saying that Pinellas County is entirely developed. There is no more open land. There will be no other landfills in the county. Our landfill currently has about 76 years of disposal capacity. And when that is filled up, there will not be another landfill in the county. And at that point in time, the county is going to be in the trucking business. So our long-term goal is to obviously make that landfill asset last as long as possible. And one of the ways we're doing that is with our waste energy facility. This just kind of gives you an idea of our campus. It's a 3,000 ton per day waste energy facility. To the left, you can just barely see the landfill. The green area behind is future landfill space, yard waste mulching. You can barely see the tire processing in the background. And then the building on the far right is our customer convenience center. We recently completed a solid waste master plan by the year 2050, we achieve, quote, zero waste to landfill, which is in reality is minimized waste to landfill. And so the waste energy plant is a big component of that. And I'll talk about what we've done to extend the life of that, but we're also looking at additional technologies to take other portions of the waste stream out, do something else with it so that we reduce the amount of waste going to the landfill. Right now, the mass burn technology, which is what our waste energy plant is, reduces the volume of waste by 90%. And then it reduces the mass by 70%. When you've permitted a landfill is basically permitted size by volume or airspace. So by reducing the waste by 90%, we're putting 10% less or 90% less into that landfill. And that's what's contributed to the life that we have. In late 2014, our facility was aging. We'd been through several operators, and the availability or the capacity factor, and when I say the capacity factor is we have a contract with Duke Energy for the sale of electricity. We guarantee them 55 megawatts. And that is 70% approximately of our generation capacity. If we go below 70%, we start losing our capacity payment. And presently, that is very lucrative. So we had a lot of money at risk with this aging facility. So in 2015, we selected a new contractor, a new operating contractor to come in and operate the facility. And at the same time, we had embarked upon a program we call the Technical Recovery Plan, which essentially is replacing end-of-life equipment and systems within the facility. The idea is to increase the sustainability, the availability, and the production. And we want this facility to last at least another 30 years. Some of the major components that we replaced were the overhead cranes. They're state-of-the-art, they're cone cranes. The heat transfer surface, pretty much all of the boiler surface was replaced. They're pretty standard carbon steel tubes, but the technology that we applied in this program was the shop applied spiral wound Inconel overlay. If anybody's got any, historical experience with waste energy power plants, they were all built with just carbon steel tubes. You could expect a maximum of 2 to 3 year life out of a boiler tube before it needs a replacement. With Inconel overlay, we're expecting at least 10-year life out of a boiler tube. 15 years would not be uncommon. Beyond 15 years is unknown at this point, but it could be pretty good. The Stoker grates are Martin combustion technology, and they were originally installed in the plant when it was constructed in 1983. But since several operators had operated the plant since then, they did not have the franchise of the Martin system. So a lot of aftermarket parts, equipment, technology, and everything else was thrown in it. At the end of the day, the combustion system was run by manual in the control room. Now, part of our TRP plan was, first of all, we rebuilt the Stokers, rejuvenated or rebuilt the combustion system, and now the combustion system runs as it's supposed to on a combustion controller. The spray dry absorber, or SDA, had pretty much the sides of it has run out, had worn out. If you could think of maybe crushing a beer can, that's kind of like what we were afraid of, what was going to happen. So what we ended up doing is we applied another metallurgical technology, not new, but new to the facility, is we lined the facility with a Hastelloy plate. Hastelloy is a very abrasive resistant, kind of very smooth metal, so that as the ashes wear against it, they won't wear out the sides of the vessel. And because it's smooth, they'll fall down the sides of the vessel into the hopper and not bridge over, which was a lot of problems before that. We have 2 turbine generators. We have 3 boiler units and 2 turbine generators. Boiler numbers 1 and 2 operate turbine number 1, which is a 55 megawatt or 50 megawatt turbine generator. Boiler number 3 operates turbine number 2, which is a 25 megawatt generator. The entire steam path or rotor of turbine number 1 was replaced. General Electric is the manufacturer of our turbine generator, and they redesigned the turbine blades with the latest technology, and we achieved a 9% additional efficiency out of the turbine. I spoke to you a little bit about the Inconel overlay on the tubes, the Hastelloy on the lining of SDA hoppers. 2 other things that we did, again, is not new, but it was a new design application, is we use stainless steel to construct the hoppers underneath the bag houses, the SDAs, and the economizers, primarily because those hoppers are insulated with wool insulation and lagging. And in the Florida environment, especially in St. Pete or Pinellas County, it's very humid and they act like a sponge. So those hoppers actually wore out from the outside. They just rusted out. So instead of, we just replaced the carbon steel, with stainless steel to prolong the life of that equipment. Also, underneath all of the bag houses that collect the fly ash or the SDA's fly ash, or even the economizer ash and the boiler ash, they all used to be screw conveyors with carbon steel bodies, and they were often wearing out. So what we've done is we just replaced every one of those conveyors with drag train conveyors in stainless steel housings or bodies. And so that should, resist the corrosion of that environment, considerably better. as I said before, we were running close. I said our power purchase agreement had a capacity factor of 70%. We were down to 75%. Since we've implemented our technical recovery plan, the facility now has achieved a capacity factor of 92%. Our turbine availability is 96.7%, which is up slightly from the 82% 75. We're combusting 836,000 tons a year, which is up from before. And our megawatt generation, 440,000, up considerably from 75. And the capacity factor is now 96% over the 75%. In short, this facility is 38 years old. It's running better today than it was brand new in 1983. There's not, and there's often months that we'll get 100% availability on all 3 units. The only difference between a waste energy plant and a utility fossil-fired boiler is those boilers achieve an equilibrium of fouling. They'll foul to a certain point, and then they'll reach that equilibrium and they'll just run. Waste energy plants never achieve that equilibrium. They foul and foul and foul. And so at some point in time, when you start impacting your ability either to achieve superheat or because of, they call them eyebrows, but it's almost like solid ash that builds up over the fire air nozzles in the furnace, you have to bring your boiler down. It's basically just a cleaning cycle, down for a couple of days, clean it up, bring it back up online, and it's up online steady for 3 more months. We've increased our ash throughput efficiency because of the management of how the ash goes through. I mean, a lot of times if there's a system downstream that goes down, then what we have to do in order to fix that, you have to bring your boilers not necessarily offline, but you got to bring them down so they're not generating as much ash, bottle it up, clear out the problem downstream, bring your boilers back up, and then let the ash go. On our ash recovery system on the back end, all of the ash generated from the waste energy combustion goes through a metals recovery process. Essentially we're only recovering 2 sources of metals: ferrous metals and non-ferrous metals. Ferrous metals being recovered via magnet, and of course non-ferrous metals from eddy current separators. We've looked at increasing or how can I say, redesigning or modifying our metals recovery operation, or redesigning it. There's nothing new. It's basically ferrous. A magnet's going to pull your ferrous, an eddy current's going to pull your non-ferrous, but it's the application of when and where to do that and how many and the sizing and that sort of thing. So we're in the process, or actually of looking at that, and then we expect to recover more metals, with that application, and that, of course, more metals is additional revenue for the operation, and B, less going to the landfill. The other thing about the improvement of our metals recovery process is presently in our chemicals collection operation, we're asking citizens to separate electronics and bring them and separate them and keep them out of the waste stream. Well, with the ability to recover more metals and more of the smaller metals with an upgraded system, we're going to start putting those electronics back into not back into the waste stream, back into the waste energy plant. The bulk of all your metals are plastics. And so that's good fuel. But with the improved metals recovery system, we can recover all the metals up at the back end. Some of the benefits of our waste energy plant is over, say, traditional. When I say traditional, basically the only other major way of disposing of your your waste is landfilling. Landfilling, and if you just bury it in the landfill, it generates methane, it generates carbon dioxide, both of which are greenhouse gases. by disposing or processing the MSW through the mass burn waste energy combustor eliminates methane altogether. And because it is combustion, it does have emissions and it does emit CO2. But the combustion of MSW through the incinerator produces approximately 19 times less CO2 than a landfill will generate. Because the United States EPA has defined MSW as a renewable fuel. Therefore, the energy generated from the waste energy plant is a renewable energy. The difference nowadays is you hear all the time renewable energy, and right behind that you hear solar and wind. The only difference is they want to qualify is clean. Clean renewable energy is energy derived from a non-combustion process. Renewable energy is derived from a renewable fuel, and MSW is a renewable fuel. And because of that, we have registered our energy with a nationally recognized registry called Embree. It's a Midwest renewable energy tracking system. And that is then those credits now become available to the nation or to any company that's looking to purchase those credits to reduce their carbon footprint. You heard before that combustion is presently the best or the best known way of destroying PFAS. The destruction temperature for PFAS is 1832 degrees Fahrenheit. The flame bed temperature of a mass burn waste energy plant is 2000 degrees Fahrenheit. And at the top of the combustion chamber, which is about 50 or 60 feet tall before those gases go to the next pass, is 1800 degrees Fahrenheit. So from Pinellas County's perspective, we feel that at least partially, we're already contributing to the destruction or the management of PFAS in the waste stream because it's being thermally treated. Also, because with our metals recovery system, we're promoting additional recycling. As a matter of fact, in the state of Florida, most communities that have the highest recycling rates coincidentally just happen to have waste energy power plants, in their community. The other interesting thing about our site is we're probably one of the only facilities in the state of Florida that do not make a distinction between stormwater, surface water, and leachate. Our entire site is surrounded by a bentonite clay slurry walls, 10 to the -7 centimeters per second permissivity. So it would take, with a positive gradient, in other words, the water level on the inside higher than the groundwater on the outside, about 3 years for the water to migrate through. But by permit, we're required to maintain a negative gradient. In other words, the water level on the inside is lower than the water level on the outside. So anyway, in order to manage that water, we designed and constructed a reverse osmosis water treatment technology. So we take all of our site water, treat that water up, and we give it to the waste energy plant for the time being as a cooling tower makeup water. So that's how we kind of like recycling our leachate and our stormwater for reuse in the waste energy plant. So that's a summary of pretty much everything we're doing, and our use of various technologies for our waste energy system and our solid waste management system. Any questions? Yes, sir.
Thank you. Great presentation. Good work. Do you have any pre-treatment recovery of any organics or recyclables prior to waste to energy?
Not on site. The only, and I'm not even going to call it pre-treatment or not, I don't even want to call it pre-treatment, almost like pre-processing. Pinellas County has a pretty aggressive recycling program, and that's curbside collection. You know, and it's mostly residential curbside. They haven't really gone full-blown commercial yet, although there are companies that have like corrugated dumpsters. But we do not on our campus. That's because the combustion technology we use is mass burn, which means it comes right off the truck, right into the pit, and from the pit into the feed hopper of the boiler.
So, but complete bags, garbage, mixed waste with also food and everything else. Do you know what the moisture content of the waste usually goes into the incinerator?
Yes, yes. Now, I know I mentioned our master plan earlier, and one of the things we are considering and would like to do is potentially remove the organics fraction, which would include food waste, do something else with that. I don't know, could be anaerobic digestion, composting, not sure.
Okay.
But that would, and I would say that organics food waste is probably a good 20+% of the waste stream. So that would reduce some of the load on the waste energy plant and give us more capacity for other waste.
One last question is, you mentioned about the carbon credits. Have you been able to certify the facility as a that you can actually export and sell the carbon credits and get revenue for them?
Yes, we have. MRETS, Midwest Renewable Energy Tracking System, is one of those companies or entities that does certify. We have uploaded a number of credits. They allow us up to 2 years, historic or retro, 2 years. Now I'm just in the process of, sometimes my own internal administrative system is the eye in the fly in the ointment, so to speak. It kind of really slowing things down. But once I've just got my internal accounting system squared away, then they're open to brokers, and we've already receiving calls about people wanting to buy.
One last question. How many tons of carbon reduction are you getting per ton of MSW? And how much are you getting for that?
Oh, I mean, you mean
Like
right.
the offset, how many
Right.
tons of CO2 equivalent per ton input? And how much is the going rate or the revenue you're getting right now?
I'm trying to think. I want to say the renewable energy credit rate. Well, let me put it this way. It'll be negotiable, but it could be as much as 35 cents a megawatt.
Oh, that's the megawatt, but the carbon credits, if you're selling them right now, they're on the basis of
Well,
ton of CO2 offset, right?
we're not necessarily selling carbon credits.
Okay,
It's called renewable energy credits.
I see.
I'll be honest with you. I'm not sure how that works on offsetting carbon.
Yeah, yeah. But what is the power rate? What's the power purchase agreement that you have? Like, what are you getting for the power?
The power right now is about it's around 3 cents a kilowatt. And you raise a very interesting question, because there's a bunch of and just about every conversion technology pro forma is always the element of energy as part of the revenue source. Well, I submit that energy is worth almost nothing. I'm getting about 2.5 cents from Duke Energy now. My power purchase agreement ends in December 24, and in January 1st of 2025, electrical energy revenue will go down to 0.1 cents a kilowatt.
Oh, good.
That's almost nothing.
Yeah.
And of course, they turn around and sell it for 17 cents a kilowatt.
Sorry, one more question. I lied.
As many
about that.
questions as we have time for.
This is a county facility. Are you responsible for collection as well? And are you getting any revenue for tipping fees?
Yes, that's where we're going to have to make the difference up in lost electrical revenue is going to have to be in the tip fees. Up till now, we have been the lowest tip fee in the state of Florida, primarily because we've offset costs with our capacity payments, but those capacity payments are going away. You know, our electrical revenue rate, as I just said, is going way down. So the only way to offset the costs is through tip fees.
How much?
Right now, our tip fees are $42 a ton. Everybody right across the bay in the city of Tampa, they're about like 76. You know, all the other waste energy facilities in the state are in that same range. So we are trying to raise our tip fees about 6% a year, basically just so that we don't go from, how can I say, is to make it less painful every year. Otherwise, we'd go from $37.50 a ton, which what it was a few years ago, to $80 a ton overnight. And that would be pretty tough for our municipal partners to swallow. So we're working together with them and trying to bump the rates.
You spend quite a bit of money on the retrofitting. Is that subsidized from the county or is that all part of P&L?
No, we spent $243 million to rejuvenate the plant. And we paid cash because of our power purchase agreement that we currently had, that we just had the money. And the reason why we spent that kind of money is we were preserving $500 million in future capacity payments.
Great, thank you.
You touched on your revenue compression in your PPA. Do you feel like that's a product of just the proliferation of solar and wind assets? So you're competing directly with those renewable energy sources, or in your opinion, what is that a product of?
I wish it was based on solar energy because I think the electrical rate would be a lot more competitive. But what they are basing that on is natural gas peaking generators. In other words, the amount of electrical revenue that we get paid is called the avoided cost. So how much would it cost the utility to generate a megawatt, an additional megawatt of electricity? And right now it costs them, they're saying 0.1 cents per megawatt or kilowatt, 0.1 cents per kilowatt out of a natural gas fired peaking generator.
So that avoided cost, they always measure, I would imagine, against the lowest cost to generate. You get no consideration for being renewable, as you stated you are.
None.
I see. It's interesting.
Well, and as far as that is concerned, the state of Florida does not have a renewable portfolio standard. If they did, then we would be a base load for renewable energy to the utility. But since they don't require that, there's no premium on our electricity. It'll come kicking and screaming because the utility lobby is very strong and the solid waste industry is not. However, we are working on forming a consortium of municipalities to push that. Now, one of the things we're trying to push for is net metering. And basically what that means is, like right now, a really good case is like Hillsborough County. Hillsborough County's waste energy plant sits on a piece of property, and right next to them is a wastewater treatment plant. And they can sell that energy directly to that plant. They're contiguous and they're the same organization. What net metering does is we could sell our electricity to the entire county government organization. You know, if the county pays a meter, we can be providing that electricity. You just pay a wheeling charge to the utility. Now, we could sell the electricity, say, to ourselves, for 9 cents a kilowatt. They're paying 17 cents a kilowatt. It's a total win-win. And so we'll see where that consortium goes, but coincidentally enough, 60% of this population of the state of Florida is represented by communities with a waste energy plant. So we'll see what kind of political pressure we can bring to bear on our legislators to see if it's substantial enough to fight the utility lobby. Sure.
Hello. Thank you, Mr. Embree. I am fascinated by everything you're saying. I just want to download your whole brain right now. I have two questions. Number one, the reimbursements that you're getting through Duke Energy on that payment agreement on that contract, is that part of or separate from the REC credits you're getting?
Separate.
It is
As
separate.
part of our power purchase agreement, we
Okay.
own the RECs. Duke Energy has.
Okay.
has,
And you're selling those RECs on a REC marketplace, I presume,
yes.
correct? Okay. Number two, you are, and I think you answered this previously, but you are doing RECs only. You are not doing carbon credits. Do you have the capacity? Is it feasible or legislatively possible for you to do both?
That's a good question, and I don't have the answer for that.
Okay.
At first, I was just trying to hit low hanging fruit and try to get the carbon, excuse me,
The RECs.
the RECs
Understood.
first. Now it's something. It's it's probably about $350,000 a year revenue. I mean, that's no small chunk of change, but in our operating system, it's not going to pay the cost for the plant.
Understood, completely understood. The question has come to me by another facility in Virginia, whether or not you can do RECs and carbon credits, but contiguously. So I was interested to know if that's something that you had done, because it certainly expands the capacity for revenue. Alternatively, the other question is, have you considered at any point investigating going into the RENs market rather than the RECs market? And renewable energy is, the RENs market is through a Department of Energy program for transportation specifically, and you're selling that electricity as a renewable energy fuel for transportation. And that is reimbursed at, I think the current market price for that is $3 per gasoline gallon equivalent, which is significantly better than the current REC market.
Well, I'll be honest with you, I'm not familiar. I think I want to have a conversation with you.
We'll have the conversation. And lastly, you said the waste energy power plants in Florida. Can you tell me one more time, how many communities in Florida have waste energy power plants?
I'm sorry, you say that again?
How many of the communities in Florida currently have waste energy power plants?
Lake County has a small 200. I have to name them off because I can't think of.
Well, I mean, but by percentage, it's a very high percentage.
60% of the population
60%.
is represented by communities with a waste energy plant.
Okay, that's amazing to me. Okay, thank you very much. I appreciate it.
Actually, I think Florida probably has some of the most waste energy plants of most of the states in the country.
Fantastic. Okay, thank you.
Question. I think RINs are typically liquid fuels, so they don't use a liquid energy source. That's interesting. Okay. Interesting.
In the area of Duke and what they're doing with your fuel or your electrical costs, Here in California, some of the communities, the cities, the municipalities have their own power generation. You may look at your closest municipality, partner with them because you are carrying Duke's baseload.
We tried everything. The problem is that the Public Service Commission for the state of Florida would not allow us to do that unless we ran our own transmission lines. In other words, we wanted to use existing transmission, pay the utility a wheeling charge, and then set up our customers. No way, unless I ran my own transmission line. So now you'd see double lines going down the street. Good. Well, thank you very much.
That was a really great conversation. So for our final speaker, I'd like to introduce, I have to get his name correctly, Peter DiCecco. He's joining us from his office on the East Coast. He wasn't able to join us, but he is going to be discussing waste to energy, ash and recycling. So if you would look at the screen to look at Peter's presentation, and then he'll take questions after.
Thank you, Theresa. I do appreciate it. And I'd like to begin my presentation by really commending Bill and the work that's been done at Pinellas County. As you mentioned, it was formerly operated by a couple operators, and one of them which was us, and you know, completing a $243 million retrofit project. I can't imagine how much work that was done, and to see the success of Pinellas County, it really does speak volumes for the amount of work that Bill and his team did. So congratulations on that, Bill. I'm Peter B. DiCecco. I'm here to talk about waste to energy ash recycling. I work for Waste Innovations, Wind Waste Innovations. I've been an operator my entire life. I was a facility manager at a Millbury, Massachusetts facility. Then I came up to corporate, worked, dabbled in procurement and supply chain to try to bridge that gap between operations and procurement. And then I assumed the role that I currently have, which is VP of Waste to Energy, which has jurisdiction over the 14 waste to energy facilities that Wind Waste Innovations owns and operates. Okay. So a little bit about Wind Waste Innovations, formerly Wheelabrator. We're a vertically integrated operator consisting of 10 industry-leading brands, which make up right now the portfolio of Wind Waste Innovations. It's a curb-to-grid waste management company, and we're designed to enhance customer service and deliver superior waste solutions for each customer. We're focused on delivering essential services to our customer, which includes waste to energy, as well as transfer stations, collections, and landfilling. We strive to exceed our customers' expectations each and every day, and we do that through the passionate professional employees that we have. Currently, we have approximately 2,000 employees, and all dedicated to delivering excellent customer service. And that also includes waste to energy. Our customers are the haulers and the customers that bring in the fuel into our facilities, and we're aimed at trying to get them in and out of the facility as quick as possible, and obviously as safely as possible. So we're renewable energy, and we're consistently solid waste. We do have one refuse-derived fuel facility located in Portsmouth, New Hampshire. But the rest of the portfolio is mass burn. And what we mean by mass burn is essentially it's curbed right into our refuse boilers. We have an intricate filtering system with regards to employees looking for things that aren't combustible or cannot make it through our boilers, and we filter those out accordingly. We're predominantly located in the Northeast with a southern reach as far as Fort Lauderdale, but essentially most of the portfolio is located from Baltimore, Maryland, up to Concord, New Hampshire. So we take pride in being responsible and innovative to waste to energy, and particularly ash recycling, as well as metal recovery. The conventional system that we have is, curb to the trucks and into our boilers. And before we go into our boilers with Wind Waste Innovations, we have several locations where we do recycling at transfer stations and municipal recycling facilities. Then the trash eventually ends up at our waste to energy facility. And from the waste to energy facility, after we process the trash, we have a intricate recycling process with the ash and the metal recovery. And then it goes into monofills, centrally located in Putnam, Massachusetts. I'm sorry, Putnam, Connecticut, and Shrewsbury, Massachusetts. And when you do look at, the metal recovery aspect of the industry, it does, reduce the amount of landfilling and also the amount of generation of the CO2 fuel. Recycling metal reduces substantial amounts of CO2 produced during the smelting and processing operations when making metal from the original ore. When you look at some of the numbers and the energy savings using various recycled metals compared to virgin ore, it's upwards to 90% for aluminum and copper, and almost 56 to 60% in steel. So we do see a significant environmental benefit from the recycling of metals, as well as a total ash solution. Being able to develop aggregates from that ash. When you look at the North American compared to the European model, we are significantly behind the European model, but it's something that we're striving to catch up with. The treatment of metal extraction at the waste to energy facility is twofold. We have the ferrous recovery, which is handled through a magnet, as Bill did touch on a little bit, that his Pinellas facility does. And there's two stages of that metal recovery on the ferrous side, and that's items over 24 inches in length, which are extracted from our grizzly scalpers that we have at each facility. And then it goes to our fines conveyor, which leads to another cross belt magnet that extracts anything less than 24 inches. From that point, our ash stream that now has the ferrous metal extracted goes into our eddy current system, which extracts all non-ferrous material greater than 3/4 of an inch. We have those facilities throughout our portfolio, and we see a yield of approximately, 0.5 to 1.5% on the non-ferrous, and up to 3 to 4% on the ferrous side when compared to total tons processed. We have an active relationship with Echo Recovery Systems, ERS, and from our ash process, we send it to our Putnam and Shrewsbury ash monofills, where ERS has their ADR operations. It's a joint venture. We established a great relationship, and at that ADR operation through Echo Recovery, we focus on fine fraction metal recovery. A very important part of being able to focus on that is to making sure that the ash consistency is consistent. And that's something that we constantly focus on at Wind Waste Innovations, to make sure that the ash stream stays consistent, so the equipment at the monofills can consistently and uniformly process it. We focus on mainly high-grade aluminum and high-grade heavy non-ferrous at the landfills. And we also have stainless steel sorting and coin sorting at the recovery facilities at our monofills. Some of the recovered products, you have the fine minerals, ferrous concentrate, large ferrous scrap, in mineral aggregates. And these are all recovered products that we cannot recover at our waste to energy facilities because we just simply do not have the technology installed at those facilities. We need to send it to our Putnam and Shrewsbury monofill to gain that recovery through the relationship with ERS. Non-ferrous product, aluminum scrap product, and that ranges in size from 1 to 12 millimeters. 80 to 85% of it is pure metal scrap, with 15 to 20% of it being residue that goes back into the landfill, as well as heavy ferrous non-scrap. Again, 1 to 12 millimeters up to a ½ inch, and most of that, 95 to 98, is pure metal scrap. So we talked a little bit about ash mineral reuse, and it's something that Wind Waste Innovations is still actively looking at. We're working with the University of Florida to separate some ash streams to make it more economical and be able to have a better recovery rate at our South Florida facility. But some of the trends we're seeing, the ash mineral reuse is on applicable minerals, the green deal in the Netherlands. And we need to focus on testing method and leaching in order to promote some environmental law changes in order for us to do it moving forward. Some of the products that we see being used in Europe is definitely, the cinder block industry, as well as the paving block industry, in the concrete industry. So those are some of the technologies that currently are being advanced in Europe that we're looking to also do in Wind Waste Innovations. A couple snapshots of really, I wanted to show you the magnitude of the equipment that we have installed. A lot of the times, there's an intricate amount of conveyors as well as metal recovery equipment that go into recycling the metal that we cannot capture at the waste energy facility. That's our Putnam, Connecticut facility and our Shrewsbury, Massachusetts facility. So centrally located near obviously the ash monofill, to logistically make it as simple as possible when we do recycle that material. And that's all I have for the group. Are there any questions?
We've got one question, Peter. We're getting him a microphone. Hold on. He's coming. Hold on.
Thank you. Thank you very much. It was a great presentation. Real quickly, I saw all the products in Europe that you're reusing the block and so forth. Do you have any programs in the United States that you're using the mineral for, active buds, that kind of thing?
No, not at this point in time. Everything that we're actually utilizing is being distributed or shipped overseas.
Okay, great. Thank you.
Well, I don't think we have any more questions. Thank you for joining us, Peter.
Thanks for having me.
Okay, I think we're on to our next agenda item. And we're a little bit early, so I think we get to go into the exhibit hall. Although Gene's coming in now and he'll set me straight if I'm wrong.